Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go. Let's go. Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go. Let's go. Let's go. Let's go.
Let's go. It's another Tuesday, and you know that every Tuesday there's only one and only IoT show in the rest of the world, and that is IoT Tuesday. Welcome, welcome, welcome to episode 44. Yes, 44 of the IoT Tuesday show. I'm yours truly, Samuel Adrani, here to give you some goodies and some fun stuff on IoT. Last week we talked about accessing or interfacing with the I/O port of the Wio Terminal. This week we're going to do the last part of that interface, and then we'll move on to something else. So when we come back, I will be showing you how to continue interfacing with your Wio Terminal. But then, let's go for our intro. Awesome. If you're just joining us, this is IoT Tuesday, and I'm yours truly, Samuel Adrani, all the way from Accra, Ghana. Well, yes, it's a Tuesday, wonderful Tuesday. We're happy to be here. If it's your first time, thank you very much for joining us. If you would be gracious enough to hit the subscribe button right here. This is because YouTube has some changes, and you can't do direct live stream onto your YouTube unless you hit 1,000 subscribers. So I'm on an agenda and a quest to get at least 1,000 subscribers before the month end, and potentially I'm being very aggressive, 10,000 subscribers by the end of the quarter. So if you like what I do here, if you enjoy the things I put on the show, kindly do us a big favor by just subscribing, hit the notification bell, so that all the cool stuff we do, you'll be notified. I think I mentioned in subsequent episode that I'm coming up with a new channel called Let's Experiment. That is going to feature more of my unboxing, DIY, more of the crazy hands-on thing I do aside just the IoT stuff. So it's going to be a combination of stuff I do on Tuesdays, Fridays, and Sundays. So to keep notified or to get notifications on that, please subscribe and hit the notification bell. So once I put that there, you will get it. Well, so what are we going to do today? So last week we started by interfacing on using the I/O port analog. We did a lot of analog last week. So today we will be taking a look at how to do digital and potentially also to do a few other stuff. But before then, I like to always bring to you stuff that's happening in the world of IoT, or depending on the show. So today, let's do this. So let's get into it. Let me share a couple of things that are happening in the world of IoT, and then we can actually get right into it. All right, awesome. So first off, couple of announcements I want to share. Let's go to my screen so I can share that with you. The first thing I want to talk about is Microsoft Build. Yes, if you're a developer or stacks in the Microsoft ecosystem, Microsoft Build is happening from the 25th to 27th of this month, 2021. So if you're not registered, make sure you go register ASAP. It's it's a gathering of all all things Microsoft developer related, so yeah, awesome, fun stuff going on there. So if you've not registered, make sure you are registered for Build. Um, the next thing I want to talk about is Tech on Wheels. Yes, so I want to take this opportunity to talk about Tech on Wheels. So Tech on Wheels is my um, personal kind of like social project I'm doing, and it's aiming to bridge the gap between technology, that bridge the technology gaps. Um, thank you, Ablam, for joining the stream. Thank you. So Tech on Wheels is a project I'm embarking on to help bridge that digital gap between people in the deprived rural areas who don't have access to it. There's a particular video I would be sharing maybe on my social media feed. A bunch of kids actually having to having to use have a keyboard drawn with chalk on their desk, which is very sad to see. So Tech on Wheels seeks to kind of like bridge this gap by literally taking technologies them in kind of like a mobile van so in areas of robotics, uh, block programming, visual programming, IoT uh, programming, pretty much anything, 3D printing, all the cool stuff that technology has to offer to take to these deprived people or kids so that they can also innovate and know that they are not limited by just their ecosystem. Right. So that's Tech on Wheels. If you want to support, join, volunteer, whatever it is, just hit me at any of my social handles down there and I'll respond to and show you how you can connect. And also, if you have any questions, so far I have two people, I think one from is it Philippines or Vietnam, and then one also from I think Japan, um, who have reached out, and kudos to you guys trying to build stuff, and they reached out and I gave them my advice and still helping them to build stuff. So if you have any questions on the things you see on the show, feel free to ask me and I'll be willing to help you. So with that out of the way, the next thing we want to talk about is some announcement on Azure IoT. Now, if you don't know what Azure IoT is, go back to my channel. I think I did um I try to put the link somewhere up here in the video um where I talked about Azure IoT Central. Now, Azure IoT Central is pretty much a Microsoft offering that allows you to develop IoT solutions rapidly without having to worry about provisioning devices and having to worry about the core things that happen beneath it. So think of it as a collection of all the Azure services specific to IoT that have been put together to create a service that you can easily kind of like plug and play and use. Miss Yako is on the stream. Welcome. How are you doing? Awesome. Hey, welcome to the stream. So, sorry, that's IoT Central. Now, there has been some update to it. For some time now, you had to, go to the portal and use Azure IoT Central. However, it's the IoT Central API service is generally available. Yes, that is generally available. That means that, sorry, you can manage your API tokens, you can create and manage digital twins, device template, you can create and onboard and manage devices just using API. So this allows you to integrate Azure IoT Central services into your custom applications or custom solutions, which is an interesting thing. If you want to learn more about it, check out Azure IoT Central on the Azure portal. And if you want me to do something, maybe revisit or do something IoT Central, just let me know in the comment section and I will do a video on that. Yes, with that out of the way, let's get to today's topic. So last week we started with the IOs, and I shared this on what's the pin or the input output pin on the Wio terminals look like, and this is the layout. So if you look at it closely, you have digital analog pins and some that can also be used as either digital analog or the pulse width modulation. And then the Wio terminal itself has just two groove connectors, but you can use this 40 pins. The Raspberry Pi, I think I showed that, I'll share it again. You can use any of those to represent and connect other things to it. If you don't have the groove extension, there's an extension for the groove for the Wio's terminal, that allow you to connect, I think, 6 or more sensors using the groove connector. But if you don't have that, then you have two. One is by default an I2C groove port. The other is a digital port that can be changed to a digital analog or pulse width modulation. So today, we saw analog last week. So today we're going to see digital and probably do I2C. And then, yeah, we'll just play around with it. So let me take you to the bench to share what we did last week. Now, you're going to see a couple of things. And I'm going to introduce a few things in today's episode. So last week, this is what we did. So we connected a button, and the button is digital, right? And then we connected the buzzer. Now the buzzer is also digital, all right? But what we did was that, and if you remember, I mentioned that. So the Wio Terminal, this is the first one here. Let me move all this. Let me move the groove cables out of the way. So this one can be used for digital, analog, and pulse width modulation. This one by default is I2C. So I'll show you a hack or a trick. If you want to convert this to be seen as a digital pin, there's a hack and a simple trick to do that. So that's what we've done. So currently in the code, and I'll share the code with you right now. So we just have here a buzzer. And the simple code is that when anytime I press this button, you see that the buzzer goes off. So anytime I press it, I don't know if you can hear the buzzer, but yes, anytime I press it, the buzzer goes off. So that's very basic because now I've connected the button to digital 0 on the Wio terminal, and then I have forced this I2C to also be seen as a digital pin that's controlling the buzzer. All right. So let me share the code. Let's go to the code. Let me share that and walk through the code quite simply. And if you have any questions on the code, please feel free to ask me. So obviously we are including the font and the TFT if you want to write stuff on the screen. I just put it there. At the moment we are not writing anything, but if you want to, we could use that. And then this is just initializing the LCD or the screen. So here, as you can see, defining the button as digital 0. All right. And then I'm defining here, even though it's LED, let me use this as the buzzer. All right, and then I'll just have to go in here and change this in here, and I'll swap it to explain something. So let's do this, and then I'll change this to buzzer and buzzer, and then we can deploy this. So once this is deployed, let me just go over the code. So first off, we're defining the button as D0, all right, D0, DDD0, all right. So if you look at, let's go back here. If you look at the schematic, all right, D0 is here, right? So that will be pin 13. That will be pin 13, all right. So D0 is pin 13. So if you were using the regular pin, you would have referenced this by 13, but because you're using the Wio's library, you can represent it, you can call it by D0 or A1 or PWM0 if you're referring to it that way. So that's what we're using, all right. Then if you look at the buzzer, we're saying what? Pin wire SCL. So this is the trick. If you want to convert the default I2C groove port on the Wios, if you want to use it as a digital output or digital port or pin, this is what you use. So you reference it as pin wire SCL, all right. And as you can see, you won't see the SCL defined there, all right. However, it's just a way for you to convert it. So it's doing the conversion on the board to, you know, to kind of like swap the pins to know that, okay, I want to reference this, you know, as how do you call it? I want to reference this as a digital pin instead of the default SCL. All right, so that is the trick. So this is a pin wire SCL. This is how you reference it as a digital, or you convert that into a digital pin. So all we are doing, there's something happening in the serial thing. So let me show you this. Let me open to serial monitor. So now what's happening is that anytime I press the button, it just reports the state. See that if I don't press it, it's 0. If I press it, it's 1. All right, it's 1. If I press it, it's 1. So I'm just using the serial monitor to show that. So as you can see, in the loop, all we are doing is that we are trying to get the batting state, which is doing the digital.read for the batting. And then as we read it, we write the batting state is, and then whatever number we get. All right, quite simple. And all we are saying is that if we have a value for the batting state, all right, and that's equal to how, which is, there's a value in it, a pin value digital of 1, then we actually do we actually trigger the buzzer, all right, to high. And when you trigger the buzzer to high, or you change it to high, it means you are applying voltage to it, and that causes it to make the beep, the beep 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 sound. The same thing happens if it doesn't see a high like a high on the button, which is if you don't press the button, it just drops the voltage and then the beep stops. All right. Now we can swap this out, not just for the buzzer, for another let's say digital sensor or connector like the LED. All right, now let's go to the bench and let me show you something here. To actually make this happen, let me push this here to the side. So if you look closely, I have this kit, the Groove Beginner Kit. For all right, now this is it's a very awesome kit. Now there's a lot of blue because the light I'm using today is blue. Let's change the color to something. All right, that's just too much. Yeah. Or better still, let's turn it off and get the actual colors of it. Awesome. So the kit here, right? This has I like the packaging and I like the way it comes. And this is also from Seed Studio. If you're interested, you can hit me up and I can, get you connected. So it has a few sensors. If you look behind it, so it has a few sensors here. Where is my pointer? All right, so if you look at this, it has a temperature sensor, it has a 3-axis accelerometer, it has an air pressure sensor, light sensor, sound sensor, rotary potentiometer, a batting LED buzzer, it has a OLED display, it has the Arduino Lotus, the Groove cables, and then micro USB. So it has a bunch of things in it. Now let's go inside. Let's move our wheels here for a moment, and then let's bring this in view. Now when you open it up, so this is how it looks like. So let me bring it much closer. So as you can see, it has, so here you can see this is an LED. Now there's something cool about the way they package this. You can see, let me see if I can bring this in here. So down here on the cover of it, they've actually provided, set up some kind of like very useful information on some of the how to read analog, how to read digital. They have also like very nicely packaged. Now if you open it on the side, check this out. So on the side you have the JTAG cables for the Groove connectors. You have the JTAG cables here, all right, and then we can close that. And then if you look at the other side too, they have I think a USB. Yeah, they have the USB cable also packed somewhere here. I mean, very, very, nice, very nice packaging. Now, so the cool thing is that, let's do this. If I, just lift this up, and I lift this up. Don't worry, guys. Well, let me just, lift this up. So this is how it looks like. All right. It comes in this. It has this. How do we call them? This standoffs. All right. That allows you to just put it here and connect. All right. Now, so this here is the Arduino shield. So if you have an Arduino, you can just break this off and put it on top of the Arduino, and then you can connect all these sensors by the JTAG to the various pins. Now, there's something cool I like about what they've done with this. Let me bring it closer to show you this. Now, do you see the LED here? Now, if you look at the top here, it tells you LED, and then you see what? It has what? D4. Now, the D there tells you that this is a digital sensor, all right, or it's a digital stuff. So if you're connecting it, you need to connect it to a digital, input output or digital pin, all right. You can see for the buzzer 2 is also digital. You can see that now. How you see the OL screen here? That is I squared C. So you see IIC. So it's two I's and C. So it's I squared C. All right. And then if we go down here, you see, yes, you see the potentiometer here. That is A0, which is telling you that it's an analog what sensor. So they've done some very cool things here. So what I want to do now, okay, because our code is still written to work with a digital output. So what I'm going to do is that I'm going to remove the buzzer from here. All right, and it's as simple as connecting the buzzer onto this one. Let's get the buzzer connected. All right. Now, the cool thing with the whole board is that if you don't disconnect it, okay, that's the thing I like about this. If you don't disconnect it, and once you power, you see all these groove lines. These are all power. So even though I just connected to one, it is drawing power to all the other components that need power. So if you look closely, there's a green light here on the shield, and let me bring this up a bit. You can see that almost all the other sensors are, so there is a I wouldn't say pre-program, but they've done some work on it to the extent that because I connected this, it's drawing power, and if you look closely to the OLED, it's actually showing me the light intensity due to this light sensor here. So now if you look closely, you see the light is 3, actually 4, in the areas of 400. I don't know if I can just bring this so it focuses. Yeah, you see that. So it's saying the light is around. Come on, let me put my finger here and see if we can focus it a bit. Right. Now that's because there's a light sensor here. Now if I come on the light sensor, you should probably see the values dropping to single values. Let's see if I can bring it closer to, yes. So you see that now it's not seeing any light because I have my fingers on the light. So it says 15. But if I take my hands off, you see that, and see the small circle at the top there, right? Now this is done by, this is something they have done, on this groove kit to allow you to play with it even without, so now if I connected the temperature, it will probably be reading the temperature as well. But for the purpose of today's session, all we want to do is that if I should press this, the light should turn on. All right, so let's do this. Let me take this off for now, and then for the sake of the demo, I'm going to break that out. All right, just to show you the code still functional. It's still functional, right? But now to do that, let me just go ahead and break this out. Okay, you can easily break that out. I just have to be careful with it. Yes, I know somebody saying, oh, but I love the way it's able to show all the other stuff on it. Yeah, like I said, even if I connected it to this one right now, temperature executive, and even if I connected it to it right now, look at that, it will still, you see that, it will still run because it's providing power to all that. But that's not what I wanted. Even if if I change it and put it on this buzzer, and then let's bring the button here. All right, so because it's sharing the power, that's why that's not happening. So let's take this out and then break this. I didn't want to do this offline. I wanted to do this so you show you. So this is what I was saying. If you look behind it, it's running the, as you can see, power. It's sharing power with these things. All right, so that's why if you connect it, you see power all over this thing. So let me carefully break this out. Don't worry. No, someone is like, Sam, be careful. Yeah, I'll be careful. It's almost like a ruler, so I just need to be. Yeah. Okay. Let me do this. Let me let me unscrew this here. All right, so that I can. There you go. All right. So as you can see, that is snapped out, and let me snap this also out. Yes, so that's snapped out, and they've done it in such a way that it can easily snap. All right, as you can see, it can easily snap out of the. Yep. There you go. Then I can actually hold this and snap this. There you go. So now I've snapped this out of the circuit. All right, and I can break this again, snap this into two. There you go. So this is also snapped. All right. So let me put this here on the side. So because of now this is snapped, this is a new one. Again, I can connect this and let's see. Let's change this. Let's see this. Let's be sure that I'm getting. So there you go. This is version 2. Okay. All right. Cool. So let's connect. Let's connect the LED, and hopefully that should function. So as you can see, let me bring the LED closer here. So if I, do you see that? So as I press the button, the LED comes on. So as I press the button here, the LED comes on. If I press it, the LED comes on. If I press it, the LED comes on. All right. So that's how to trick the default I2C port um, to be a digital, all right, pin. Okay, cool. So let's get back to now that we've seen how to do the digital. Okay, the next thing I want us to do is, okay, even for the digital, let's see. We can do a servo. Okay, let's do the I2C, because now we've seen how to do the digital. All right, let's do the I2C. So for the I2C, you're talking about things like the OLED. All right. Let's go back to the bench. So this OLED here, that is an I2C. All right. This is an I2C. I think there's another one that's an I2C. Yes. So here you can see another one here. So here the pressure, okay, the air pressure sensor is also I2C. The 3-axis accelerometer is also I2C. All right. So if you want to use these sensors, we can just connect them to the second by default I2C and reference them. All right. So I think, and then also I believe this this, I think, yeah, this LCD as well is I2C. Okay, this is an RGB. This is actually an RGB. Yeah, LCD. It's an RGB LCD, which is we can change the backlight to any of the colors, and it's also I2C. All right. Okay, so let's move this here, and then let's do the I2C one. Let's take it. And hey, if you have any questions to this point, please feel free to share that the question with me. All right. So there we go. So let's see, for I2C, what would we connect? Let's see. Yeah, so we have, let's see. I think we should have the libraries already installed, right? If we don't have that, let's see. So let's go ahead. So to do the I2C, I'm going to try to add another library. All right. So let's go ahead and include um, uh, So we can include the RGB underscore LCD dot H. I'm not sure if, you know what? Let's see, RGB LCD. Before then, let me try to add this. So let's include the wire. Let's see. You know what? Let me check this just to be sure the RGB is already installed. If it's not, we would have to install it. Yeah, we'll have to install. Yeah, I think it's already there. Yeah. Yeah. So I think, yeah, I think we have that. I think we have the Arduino library, so we are fine. Because by default, if you install your Arduino IDE, you will get you should get all these things. So yeah, we're good. All right. So we have all this there. And the other thing we also need to do now, we need to specify that, you know, RGB. So we can call this RGB underscore LCD. And then let's just call this the LCD. So the LCD is going to represent our LCD that we want to connect, which is this one. All right, we're going to connect this one. Okay. So we bring that in. Well, we can still, don't worry, we can still maintain all these things. Now, however, now and I want us to define, let's define a few colors to make it easy for us to, so let's call this a constant int of, let's call this color, I'll call this color red, and then this will be 255. All right, and or let's just say color. Okay, so because we want to mix the colors, let's assume that we want, because you know that a combination of RGB gives you a particular color. So let's just do them this way. So let's say color R, I'll make it 255, and then I'll do a constant for the other colors as well. So we can do RG, and then let's set G to 0, and then let's set B, which is blue, let's set that also to 0. All right, so just basic things, defining some constants that we can use in the setup. All right, in our setup, we don't necessarily, oh well, we can leave it running, there's no problem. We can leave this TFT run, we can set the rotation, we can leave the back color, we can leave the text, that's fine. Now, so what you want to do now is to do something like the LCD, all right, dot begin, all right, and we want to set the LCD to the number of rows and columns. If you're using the LCD, that's how it works. So if you look at this, in terms of rows and columns, all right, that's how you set it up. So I want to set it to 16 columns and 2 rows. Okay, so let's do 16 and 2. Right, so that sets it up, and then I can do LCD dot begin. No, we've already begun that, so let's do LCD dot set RGB. All right, so what we're doing, we are setting the color, and remember that I created some constants for the color up here. Yeah, right, so I can set it as color R, color G, and then color what B. All right, so now at this point we don't really need the button and the buzzer and all that, so we can actually get rid of them. All right, we don't, well, this weight, I can still use the weight. All right, but we don't need this, so I'm just getting rid of the button and defining this. All right, so that's pretty much it. And then, so with this, we don't need to set a pin mode because we're not using any thing yet. So once that is set up, I can actually go ahead and say, once I'm setting it up, I can do LCD dot print. All right, and I don't need this for now, so let's just get rid of this as well. Don't worry. So I can say lcd.print, and then I can say print IoT Tuesday. All right. I just want you to print this. And what do we do in the setup? Since we are not okay, let's get rid of this for now. All right. Since we are not using any of those. Actually, let me clean it. Let me clean it up. All right. So we are not using the font. We are not using the TFT. So let me clean this up. So we don't need a TFT here, just to make the code. Or you know what? Let's do this. Let me undo everything. Oh no. Yeah, so let me copy the whole of this. All right. And then let's do a new. And then let's paste this here. And then let's call this save as. So let's go, let's save it in the right place. Okay. IoT. Yeah, we use utility. And let's do a new folder and call this, let's call this I2C. All right. And then let's call this I2C. Let's put it here. Okay, so for the I2C, we don't need a font, we don't need a TFT, all we need is write the wire, and then we don't need that. So we keep it clean. We don't need the whole of this. We don't need a serial at the beginning. We don't need this. Okay. We don't need this. So yeah, we don't need this as well. Because someone will say, Sam, show me the code, give me the code. So we're just doing, yeah. And then in the loop, yeah, we don't need all this also in the loop. So I can delete this. However, the only thing I want to do in the loop here is probably set the cursor and show how that works. So I can do lcd.set, set cursor. And then, so I want to set the cursor on column 0, line 1. All right, because you're doing 16 columns by 2 rows. All right, so set it on column 0, the first line. All right, that's what we're doing. And then let's say I want to do something very basic or simple, like saying that let's print the number of seconds since I kind of like restarted or reset it. All right, so I can do lcd dot again print. We're just doing a very simple. So mils, all right, is actually a built-in function, right, divided by 1000. So there's actually a function within Arduino. So, and then we can delay for like a millisecond, and then we can do that again. So very basic. So this is how you use, and I just will have to make sure that now I connect that to the I2C port on the Wio terminal. All right. So let's check our code and make sure it's fine. And if everything is okay, we can go ahead and then connect it. So let's go to our bench. So all we're going to do is this second part, the one away from. So someone will ask, how do I know which one is the I2C by default? So here, the one with the round thing is the first one, which is the digital one. The second one is the I2C one. So just take the whole of this out. And then let's bring this. So here, I'm connecting this to it. And if you like, we can change this and do the OLED as well. Okay. So let's connect this, and then we'll connect it to the I2C. All right. So this thing can be it bends funny. All right, so let's put this here, and I'm just going to go ahead and deploy the code. So fingers crossed, let's deploy it. Whilst that's happening, I'm going to go to the Wio Terminal, the Seed Studio um, website. All right, and then I'm going to verify that it's done. Hold on. Let's see. So we deployed this. Okay, let me actually turn it off and turn this back on. Let's see. So let me redeploy this. Okay, so this has been redeployed. Setup is fine. Oh, hold on just a sec. This is okay. Let me restart this. Bum, 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 bum. And then, okay, so let's switch back. I'm just redeploying. Let me test this again. Something. Hmm. Now, so what I was saying was that I'll go back to the Seed Studio page. Okay, let's deploy this. So yeah, that seems okay. So let's now go back again to the bench and see what's happening. Yes, that's deployed. Okay, is my not even power is coming out? Could it have been malfunctioned? I've had this for a while now. So ground VCC. Man, this is okay. Hold on, let me take this out and reconnect it well. It seems not to be okay. There you go, connected. And then let's connect this. Okay, and then I would reboot this, unless of course not even power. I'm suspecting there's something wrong with. Do I have another one? Hold on, let's see. I think I might have another one. The one I have is not Groove. This is another one I have, but that's not the Groove one. Let's see. Okay, if we don't have Groove, let's do this. Let's go back to let's try to use this one. Okay, the OLED here. It's also I2C. All right, let's use the OLED here. So let's go to the Seed Studio page. All right, and then let's try to use the OLED here because this one is not working. So let's take this out and then let's again brick this. So I think I'll be more careful with this one. Yep, this one. Okay, there you go. Not bad. There you go. Awesome. So we have this. Okay. So yeah, we have the OLED, and it's also I2C. All right. So now let's do this together. So usually what I would do is I would go to Seed. Let me bring a tab here so we do this together. So I'll go to the Seed Studio, and actually we can do the wiki and look for OLED. So let's look for the OLED. This. Oh, so in just by the way, so this, let's stop this and go back to the page. This was a cool project. This particular project, very cool project by one of the geeks in the IoT community, which actually used the Wio Terminal's tiny ML capabilities, and then with a 3D printed nose, and was able to detect different smells. All right. So one thing that I am interested in is actually, as part of the Wio Terminal thing, next week what we're going to do is that we're going to do the, how do you call it? We're going to do networking, so connecting the Wio Terminal to the Azure cloud. So we'll do IoT Hub and then we'll do IoT Central. We'll do that. But as part of a side project, I want to do the same one. This nose thing. So it's using tiny ML to be able to tell, the what smell it is. And this is connected to Azure, right? And that's another good thing you need to know. Wio Terminal is Azure certified, so you can connect it to Azure and have all the goodness and all this, secured stuff like that. So there is actually a 12 lessons and 15 project on it. We'll do that. I'm intrigued by, the fact that there's, a 3D printed nose, there's a sensor in there, and then, we can play. So this we might show the code part of things on IoT Tuesday, but the actual building process would have a less experiment. That's why I say that if you've not subscribed, make sure you've subscribed so that when we're doing this on Let's Experiment, you can actually see that. All right. Yeah. So, and yeah, thanks to Edge Impulse, a lot of these things, cool. So anyway, let's continue. So let's go look for our OLED. So what do we have? Yeah, and that's a best practice how to. So yeah, we have an OLED. I think this is it. 0.96 SSD1. Yeah, so this is it. Okay, there's also, okay, so this, I think this is it. This is the Groove one, SSD1315. Yes. And look at the price. It's just $430. So if you want to get one, yeah, why not? Yeah, after the Wheels terminal, we'll move to another dev kit and do a long session on that. But yeah, we're trying to do the very core things of the wheel, and then we'll move on to another board. So this is it, right? The same thing we have here. So let's go all the way down, just like they do it. So pretty much, the display is shown. Where is that? Where is that? Where is that? Groove interface I2C, as you can see. Documentation. Yeah, this is the wiki. This is what I was looking for. So let's hit the wiki. You can also look at the demo if you want to, but we just want to use that. And this is just best practice. You need to understand or know about the data sheet, okay, before you do other stuff. There's nothing wrong with it. You need to reference the data sheet and know how it functions to use it. So if we go down, Arduino, we can see this. So as you can see, so you need to plug it into the I2C, Groove port. And then this is what we want to copy, all right? So it says what? Include and manage library, search include. Okay, so we need to include this library U8G2 to use it. So let's do this together. So let's open here. So let's open this. No, this is not it. It's actually close this one. Yes. So this is what we're doing. So let's go ahead to Sketch, include library, manage libraries, and then we will look for. So let's put in the search here. Wait for it to load. Let's paste that here, U8G2. Okay, and then let's search for it. So I think there you go. So the U8G2, right? So let's see there. Okay, this is the latest, and then let's hit install. So we're going to install the library into our Arduino IDE, and that makes that library accessible, to us. Right? So we'll not use the LTD anymore. We're using this specific one. Yeah, and then you can look up other sensors. So if you have from the Groove kit, you can look up all those sensors and connect them. Quite easy. Is that installed? yes, that's installed. All right. So hold on, make sure we've installed the correct one. So let's go ahead and do this. Yep, yep. Okay, cool. So we have it. So we can close this. So now that should be part of, and then let's go ahead and let's borrow this. Well, let me just pretty much, let's borrow all the code from here. And I always go all the way down in my code and let's paste it because we're going to change it, so not to worry. Okay, so these are the things we define. So we're going to, and so this here is a test, all right, to determine whether to load the wire.h or to load the SPI depending on the board. But because we know we're using wire, we wouldn't stress that much of it. But let's just go ahead and add the whole of this to the top. Don't worry so much about that. And yeah, so this set it up to use setting up the clock, the reset, and all that. So telling it to use a high-speed one. So let's copy this. Yep. Oh yeah, we can just. Let me just reduce. I'm just minimizing this so I can make the copying a bit easier for everyone. So you can see that. So let's cut this. And yeah, so we are setting it here. We don't need this constant anymore. If we're using the RGB, then we'll use that. So we set this up. And I usually prefer to put my comments on the top so it's easier to read. And okay, and the setup, all we are doing is call the begin. So we don't need this, and then we can actually get rid of this loop. So in here, this is all we're doing. All right, so now let's make this big. Okay, so we're including the Arduino library, the UAGL library that allows us to use the OLED, and here determining whether to call up the SPI or the wire, and then we're just giving it, setting it up called U8G2. And as usual setup, we want to begin to use it. We are clearing the buffer or clearing the internal memory of it, setting the font, as you can see, and then we're just writing hello world beginning from 0 10, just like we do with almost all these TFTs. And then we send this to the buffer, wait for a while, a minute, and then the cycle just continues. So let's check this code and make sure that the code is clean. And once that's happening, we can go ahead, all right, and then connect where is that? Where did that go? Okay, so let's prep this. All right. So that's loading. Well, whilst that's happening, let's go to the bench. So I have connected the OLED. Okay, let's get rid of this. And the OLED is right here. So let's connect it and let's see if I can just round it up. Okay, so it looks like it worked fine. Let's deploy it. So I'm just trying to do this. Okay, and check that out. So let me bring it close here, and you can see it's written hello world. Hello world. Very simple. Let's change this to IoT Friday. Did I say IoT Friday? It looks like I'm in a hurry for Friday to come. So let's deploy this again. And then hopefully this should change to IoT Tuesday. Let me bring it here. And I know, so the question, so someone will say, okay, let me bring it closer. It's trying to focus. Hold on. All right, I'll try to make it focus a bit. Yeah, come on. There you go. Well, it's not that very, it's because of the light, it's a bit blurry, but let's take it back and see if it's going on. Let's see. Well, so it has IoT Tuesday on it. I'm just having a problem adjusting. However, that's how simple it is to interface with the Wio's analog, digital, I2C, SPI, which is for the serial kind of like communication with it, like serial peripheral interface. We can talk about, that's more, interfacing with the serial, like serial platforms. However, that is the end of interfacing with the Wio Terminal. Next week, we're going to talk about networking. And networking in the sense that we're going to talk about how to connect the Wio Terminal to Azure IoT Hub and then also IoT Central. So if that sounds like interesting to you, make sure you make a date with us next week. Um, Connect with us. Let me know your feedback, what you think of, the show. And then, hey, if you have any questions, don't hesitate, ask me, and I'll be more than willing to answer. Until then, stay positive, stay safe. Let's make the world a better place, one project at a time. And feel free to explore yourself. And hey, let's love one another. Until then, catch you again next week for another episode of IoT Tuesday. I am yours truly, Samuel, and I am